Alright, so I thought we would take a quick look at these new inductors that I got. I think they're going to work better as a makeshift voltage booster. Of course, voltage boosters come in modules. I would not really make one on my own other than for fun, because they're not very expensive. These cost like 50 cents each, and you can get decent voltage boosters for like $1. So in any case, we got the inductor there. Power supply is set to 5 volts, and this inductor, 330 microhenry, can handle 3 amps of current flowing through it. When I press the switch, you can see that's about how much current we got flowing through, about 0.8 amps right there. So it should not get too hot. This resistor will probably get fairly hot though if we keep pumping current through it. But in any case, you're just supposed to rapidly switch. So as long as I release the button pretty quickly, we shouldn't have too much current flowing, kind of steadily through that resistor. 5 ohm, 10 watt resistor. So we can easily get up to about 15 volts. I have a Zener diode to keep it below 22 volts. But right there, it looks like the current that is leaking through the multimeter, and also I think this capacitor might be leaking more current than it normally does. You can see the voltage drops kind of rapidly. When I was using a larger capacitor, I had to hit a whole bunch of times to get the voltage up, but it kind of held the voltage better. So that might be a problem with the capacitor. But in any case, main takeaway, you could see that we were able to boost that voltage. So again, you would actually use a voltage booster module. Again, they're not that expensive. They might even be cheaper to just buy than you buying the components and putting them together. For some reason, the modules seem to be cheaper than the individual components, so you would just buy that. But still a fun circuit. So zooming in, this is the setup I had so we can measure the voltage across the capacitor. There's the negative side of the capacitor to the negative rail, and then the positive side. These are polarized, you got to put them in the right way. And that little jumper is going right there. And before we take this apart any farther, I could have just turned the power supply off, but we will disconnect the cables to make sure there's no power coming to the circuit. And now, when we first measured the voltage of the capacitor, we had 5 volts at the rail, and so you can see we got this path there. There's a little wire over there, looks like this one on the other side there. And we got a diode right there that's forward bias, so current can go into the capacitor and charge it. And we saw it's about 4.7 volts, so current kind of trickles through these, but they basically drop about 0.6 volts, but current will trickle through a little bit after that. And so we got the voltage probably about 4.7 volts. This right here is the Zener diode, reverse bias 22 volt Zener diode, and I just want to make sure I stopped at 22 volts when it came to charging the capacitor. If you try to charge above that, current just goes through the Zener diode, preventing that from charging any higher. So in any case, that's with the switch open. When we close the switch, now we have a current path through the inductor. So it doesn't conduct instantly, but when it comes to how quick I can press and release the switch, it's practically instantly. And so there you can see we got that path to a ground. We would get more current and a better effect with the lower value resistor. When I look at schematics of voltage boosters, I don't even see like a resistor down here, but I want to be safe for now. And so in any case, we got that resistor there. Again, 5 ohms, bringing us close to about, since we're using a 5 volt power supply, close to an amp, as we saw, 0.8 amps. So you press that, that gets the current flowing. Again, you'd want to make that as brief as possible, quicker than what I can press the switch, but this is just a demonstration circuit. See what's going on. When I release it, as I said before, the inductor doesn't start conducting instantly, but as fast as I can press this, it's kind of instantly. When I release it, it doesn't stop conducting instantly either. Inductors, in a way, resist the change of current, and the current does change, but not instantly. So current keeps flowing, then it can push through the diode. It has to raise the voltage to keep current flowing. And so that's why if you don't have a path for the current to go, you might see a big spark where there shouldn't be one. But we have a path here into the capacitor. So it pumps current into the capacitor and raises the voltage of the capacitor. And I don't think I mentioned it before, but this is a 10 microfarad capacitor right there. that can be charged up to 50 volts. So I was stopping at 22 volts with the Zener, because earlier I was using a 1000 microfarad capacitor, and it could only be charged at 35 volts. But yeah, there you can see these pins are wires are kind of flimsy or whatever, so I don't know that they are making the best contact in the breadboard. So I might find a better way to connect this to the breadboard later on. But any case, again, this is just a prototype for fun. I'm not going to make a schematic of this particular circuit, at least at this time, for those that like that. Again, Zener diodes, you buy them at different voltages and stuff. So I just pulled this out. There's a whole bunch of baggies with different Zeners with different voltages. Whatever the voltage is written on there is where it will start conducting. And sometimes they mislabel this though. Maybe it's not even actually a 22 volt, but I'm pretty sure it is. I've used this one before and put it back in the baggie. But any case, rambled on long enough. Hope you still enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next one.